G'day YouTube, welcome back to the VK8FOS YouTube channel. The topic that we'll be covering today is one that a lot of my viewers have been requesting lately. We're going to be setting up and operating a 2G GSM based transceiver station using a software defined radio. Just a warning to you guys, we're not actually going to be running the base station in this video today, as there's going to be a ton of configuration needed for our lab environment. Part 2 will probably be the installment where I demonstrate the base station features at this stage. Also, Aaron from the SEMA Executor YouTube channel has covered this topic extensively on his channel already, and his videos are way better than mine will ever be. So yeah, make sure you guys go and check out his videos on the subject. They're really, really good. So obviously this tutorial series probably isn't going to be the fastest and cheapest way to get started with experimental SDR-based 2G cellular base stations. However, YateBTS for the BladeRF has the most features of all the free and open source cellular base station software suites. It has the advantage of providing telephone calls between two mobile phones. It supports the sending and receiving of SMS messages. A data connection from the base station and the mobile phone is provided by GPRS. And some of the lesser known features of it are a chatbot called Eliza, which can be contacted via SMS messaging, an interactive voice response IVR engine called David that can be accessed via a telephone call. Later on in the video, I'll be demonstrating all those features. So before we get into it, I'll take a moment to mention that in order to follow this tutorial, it will require you to transmit RF radiation on a portion of the radio spectrum that you are not licensed for or permitted to use. This creates some risks, such as causing destructive interference to licensed radio services that are permitted to use that portion of the RF spectrum. So please follow this tutorial at your own risk. I won't be held responsible for any legal trouble you get yourself into because you got a knock on the door from your country's spectrum regulation authority. So don't try this at home, kids. So with all that out of the way, let's talk about the software requirements now. Firstly, we're going to need a Linux distribution, and my distro of choice is always DragonOS Focal X by a good friend of the channel, Aaron from SEMA Executor. This has all the software tools we will need to configure and operate our experimental 2G base station. I highly recommend running DragonOS Focal X on bare metal, or simply put, installing it natively to your PC's internal storage. If you aren't a regular Linux user like myself, you can install DragonOS Focal X to a bootable USB thumb drive. Using Linux in a virtual machine will result in various errors and weird behavior due to buggy and glitchy USB pass-through implementations and reduced performance due to the virtualization overhead. The software implementation of our 2G base station will be running, on the PC side is called YateBTS. More specifically, the company that produces the BladeRF, Nuand, forked the original YateBTS code and tailored it specifically for the BladeRF. This is what is included out of the box in DragonOS Focal X. And while we're on the topic of Nuand and the BladeRF, in this collaboration video that Aaron and I did, we actually speak to Rob from Nuand on the phone through a YateBTS BladeRF based SDR base station. So yeah, that's really, really cool. So go and check that video out if you haven't already. So we'll move on to the hardware requirements now. So this will be the beating heart of our project, and it is the main device we'll be utilizing for this tutorial. This is a BladeRF 2.0 Micro XA4. This will function as the RF interface of our 2G base transceiver station. My model is specifically the XA4. It is the entry-level option in the second iteration of the BladeRF hardware. So as you can see, it's very, very pricey. In Australia, it's almost double that. So, yeah. Barrier of entry to this hobby is very, very cost restrictive. So the reason why we have to use this is simply because it is a full duplex transmit capable software defined radio. So full duplex essentially means that the BladeRF can transmit and receive signals simultaneously at the same time. And that is what we need to operate a cellular base station. So the base station's always transmitting, but it's also got to receive the signal coming back from the phone too. So it's a bi-directional link. A lot of my viewers are probably wondering if the HackRF is capable of being used for this tutorial, and that is a really good question because the HackRF is transmit capable. However, it is only half duplex, which is very unfortunate, meaning the HackRF can only transmit or receive at a single time. So unfortunately, it will never be possible to use a single HackRF as a cellular base station. Let's talk about antennas now. We're going to need a minimum of 2 cellular antennas with 90-degree SMA male connectors. This is called an SMA connector here. And the reason we need a 90-degree one is because the RF ports are on the, well, mounted horizontally, so we need to put a 90-degree antenna on it. But you guys knew that already. I don't really need to explain that. The 2G base station software only utilizes one transmit port and one receive port on the BladeRF. So you only need a minimum of 2, but if you want to, you can populate all 4 of them with an antenna. I'm using these ones specifically from Core Electronics in Australia. They work really good in my experience. Thirdly, we're going to need some GSM-capable mobile phones. This is so we can generate some GSM traffic, such as voice calls, SMS, and GPRS data. So I've got a Samsung S8 and an S9 in my lab environment. If the mobile phones you guys are using have the option for a 2G only mode, you can configure that, but it's not a strict requirement. So the next thing we're going to need is we're going to need at least 2 SIM cards, one for each of the mobile phones in our lab environment. I'm using these SIM cards from Sysmocom in Germany. They are very, very good quality and work extremely well for 2G base station experiments and also LTE 4G base stations as well. I'm going to make a video on LTE base stations at a later date for you guys also, so keep an eye out for that in the next few months probably. And finally, for the sake of completeness, I'm going to say that we will need a working computer running a DragonOS FocalX Linux with a minimum of 1 available USB port. You will also need an internet connection to follow this tutorial. So before we can deploy our 2G base transceiver station, we will need to do a whole heap of software configuration on our PC or laptop. So we've got to run a few commands first. So I'll start by copying and pasting the following command. I'm going to bring up my terminal window. You guys do the same if you haven't done so. And we're going to run this command here. So I'm going to hit enter on that. That command will launch the Apache web server and allow us to configure YateBTS in a pretty GUI inside our web browser. So I'll go back to my browser now, open up a new tab, and we're going to browse to the following address in our address bar, localhost/NIPC. I'll hit enter on that. And in the web browser, we're greeted with the subscribers tab of the YateBTS configuration GUI. And essentially, this is the tab that we're going to input our mobile phone SIM card details into so they can connect to the base station. So this here is the email that Sysmocom will supply you when you purchase their SIM cards. The minimum you can buy is a 10 pack. So that's why there's so many different ones listed here. The IMSI values listed here in the left-hand column are the unique identifiers of a SIM card on a cellular network. The first 3 digits are called the MCC, which stands for Mobile Country Code. So if we turn our attention back to the web browser, we're going to click on Accept by Regular Expression button down here. Oh, sorry, I don't think you guys can see that. There we go, that's better. I'm going to click Accept by Regular Expression. Okay, so what we'll do is we're going to write the caret symbol, and then we write 999, which is the first 3 digits of my SIM card's IMSI numbers. And then I'll just hit save. Now that we've configured our SIM cards, we can now switch to the country code and SMSC tab. In the country code field, we will type 999. And 999, and in the SMSC field we enter a star symbol, and you can do that by pressing Shift and 8 on your keyboard, and then we hit the save button. Next we will enter the BTS configuration tab. There is a number of values here that we need to configure, so I'll just get straight into it. So the radio band I'm going to be using is called eGSM 900. And the C0, so that is the uplink and downlink combination frequency. So it's the ARFCN. So anyone that's familiar with GSM knows what an ARFCN is. So I'm going to scroll down and I'm going to select number 1. So so you can see here that there's 4 different frequency bands that can be configured. Whichever one you opt to use, you have to make sure that you are selecting a C0 that is relevant to your band that you've selected. So I'm using eGSM 900, so I have to choose an ARFCN C0 value from the eGSM 900 section. If you choose, if these values are mismatched, it will throw an error. So just be aware of that. So when we're talking about frequencies and channels and this and that, my recommendation is that my viewers should do their own research on which frequencies are best for them to use and ensure that they are not interfering with any licensed radio services. So we've got a few more values to enter into this screen now. So the first one is identity MCC. So we know that our MCC of my SIM cards is 999, so I'll proceed to enter a 999 into that field. Identity MCC, MNC. So MNC is the 4th and 5th digit of your of the IMSI number of your SIM card. So it stands for Mobile Network Code, I believe. And we can see here that my SIM cards are 70 for the MMC. So I'll proceed to enter a 70. And everything else we can just leave as default. So I'll hit submit. Now the next thing we need to do is click on GSM Advanced. And I'm going to scroll down and look for the field that says MS Power Max. Okay, so it's set to 33 by default. So I'm led to believe that these 2 settings here govern the transmit output power of your mobile phone. So how it essentially works is the base station knows through the timing advance how far away a mobile phone is from it. And if the base station is receiving perhaps a weak signal from the phone, it will say, hey, I'm having trouble hearing you. Can you please output more transmitter power? because we're doing tabletop experiments, there's no reason for this to be set so high. So I'm going to change that to the lowest value to 5. And also, if your phone and SDR are in close proximity to each other, you can actually overload the front end of the SDR if the phone, because a mobile phone will put out 2 watts at maximum power. That's a lot of energy when your base station is in close proximity to the phone. So yeah, always set that to the lowest value. And after we've changed that, we need to again scroll down and find the field that says radio RX gain. So I'm going to change this to 1. And the reason I do that is because, again, we're conducting tabletop experiments inside a lab environment where the SDR and the phone are going to be in very, very close range to each other. So there's no reason for the receiving gain to be cranked up on my BladeRF. Receiving gain is like the level of sensitivity the BladeRF's receiver will be listening for the mobile phone signal. So close proximity, there's no reason to have these values set really high. And I think that's all we need to do for this one. Yes, and we hit submit. And the next thing we're going to configure now is we're going to configure GPRS now. So we're going to click on the GPRS tab. Just confirm that your enable tick box is enabled. I believe it's enabled by default, but just double check that that is actually enabled. We're going to go to the GGSN tab, and in the DNS field, we need to write 8.8.8.8. We put a space, 8.8.4.4, and we press submit to save that setting. Okay, so we're finally done with configuring YateBTS now. A lot of these settings probably don't need to be changed for you, but I've been using YateBTS for a few years now, and these settings work well for me, in my experience, of course. So we don't need the web browser anymore, so I'm just going to minimize that and minimize my PDF here. So what we're going to do now is we're going to configure IP routing for the GPRS internet connection. So GPRS is the bidirectional data link between the mobile phone and the base station. A lot of my viewers are very young, so you don't remember the days of 2G, but I remember 2G very well. I was an extensive user of 2G mobile phones back in the day, and I remember how slow GPRS was. So, but anyway, just because we like to play around for experimentation and education, we're going to configure it anyway. So if we focus our attention to the terminal window here, I'm going to copy and paste this next command. And I'll hit enter on that, and nothing happens. This is normal, don't freak out. There's actually 2 more commands we need to run to configure GPRS now. But they require us to modify them. So what we need to do is we need to find the name of our Ethernet or Wi-Fi adapter. And that's so we can append it to the next 2 commands we need to run. So in my second terminal window here, I've got this command. So I'll hit enter on that. And after a short amount of time, that is going to show me the names of all the adapters, network interface cards in my computer. So this is a server motherboard, so I've actually got 2 Ethernet ports on it, but I know for a fact that my computer is using that there for its internet connection. The reason we need to configure this, guys, is because your computer, once this is all up and running, will share its internet connection with the base station and in turn allow your phone to browse the internet. So that's why we need to do this. So most people use Wi-Fi nowadays. If you are using Wi-Fi and you're struggling to find the name of your adapter, it probably starts with WL, wireless LAN. So If you're using Ethernet, I think it's EN or ENP or something like that most of the time. So I'm going to copy and paste the next command. And we will need to modify it briefly. So as you can see here in the command, I've got this text here saying edit me. So we need to actually remove that text. And I need to copy and paste my network adapter that is providing my computer with an internet connection currently. And I hit enter on that. So we need to run one more command now. This one will require you to also remove the edit me text here. And then I paste once again the name of the adapter providing my computer with an internet connection, and we hit enter. So yeah, that is how you configure the GPRS connection and the IP routing for our mobile phones. So at last, we've reached a segment of the video where we can initialize and start up our experimental 2G base station. But I think at 22 minutes, this video has overstayed its welcome a bit at this point. So like usual, I'm going to split it up into smaller parts for you guys. So yeah, that'll conclude part 1 today. Keep an eye out for part 2 in the coming days, or maybe next week. Thanks very much for watching. Bye.